So we'll deal with some of the limit problems, and before that I would do some concepts related to indeterminate forms. So in calculus we know if there are two functions fx and gx, and we have to find uh, limits of that. So in calculus, when the limit of the sum, difference, product, or quotient or power of two functions is taken, then we individually find the limits and add, subtract, multiply, divide, or exponentiate, and then find the limit. So, for example, if we want to take limit extends to a of f of x plus g of x. So we, by limit laws, we find x tends to a f of x plus limit x tends to a g of x, and then add. So this is same with subtraction, multiplying, divide, and exponentiate. So in this, some cases we get the result in such a way that we are not able to evaluate the expression. Those are known as indeterminate forms. We end up with indeterminate forms during the calculation of limit, where we are not able to decide what limit would be. And this is 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, and 0 raised to power 0, 1 raised to power infinity, and infinity raised to power 0. So these are the indeterminate forms, and whenever we end up with some questions like this, then we apply different techniques. So the first problem here is x tends to infinity and x cube plus 7 and 4x cube plus 1. So if I put x is equal to infinity, we end up with this situation, infinity by infinity, which is indeterminate form. So now we use another limit law to solve this problem. We know that limit x tends to a f of n, f of x 1 raised to power n. We can solve first, we can find the limit of f of x when x tends to a, and then find 1 of nth root. So this is one of the limit law we'll use here. So we end up getting like this, limit x tends to infinity x cube plus 7, 4x cube plus 5. So now we'll deal with discuss another two concepts here. So first concept is if limit x tends to infinity, k over xn is equal to 0, where n is positive rational number and k is real number. So we know that in the denominator, as x increases, xn will also increase, and when we divide it by increasingly higher number, like denominator has increased, if we divide it by increasingly higher number, then the result or will decrease. And as we divide it by increasingly higher number, the result is increasingly low and it is close to 0. So that's why we get this limit equal to 0. And the another concept similar is limit x tends to negative infinity, k over xn is also equal to 0. This has the same logic. Here n is a positive rational number and k is any real number. So this works okay for all the values except when n is equal to half. We know that we cannot find a square root of a negative number. Sign of k here actually will not affect the answer. Limit will be still same, as whatever the sign of k, we will have a constant divided by a very large number, and which will give in a result as a very as a small number. So larger x results in smaller fraction and it is closer to 0. However, k will affect the direction with which it is approaching. So suppose if it is 1 by x, then the way it is approaching to 0 as x tends to infinity and negative infinity is this. And when it is 1 by x, the graph negative 1 by x, the graph is like this. So k doesn't, the value of k will not affect the result or the limit. It will still be 0, but the direction with which it approaches 0 will be different in each cases. In 1 by x, as when x is positive, all values are positive, and when x is negative, all values are negative. And in this, it is reverse. When x is positive, 1 by x is negative because it is the graph of negative 1 over x. And here, when x is negative, 1 over x is positive. So now going back to our problem, we were doing like this is limit x tends to infinity, x cubed by 7 plus 7x, 4x cubed by 5, So now how we'll solve it? We see the largest power of the denominator and we need to factor it out. So we do this so that we do not get divide zero in the, we want to avoid getting zero in the denominator because and so that it doesn't get division by error method, division by zero error. So this is 5 by x cubed and this x cubed will give 1 plus 7 x squared. So this cancels it. Okay. Now we can find the limit of the numerator x tends to infinity. This gives 1 over 7x squared and this gives so we know that limit x tends to infinity or limit x tends to infinity 7 by x squared. This gives limit x tends to infinity 4 plus limit x tends to infinity 7 or 5 by x cubed. So this gives us 1. We know as 7 by x squared as x tends to infinity, 7 by infinity is 0. So this gives 0 and this gives 4 plus 0. So this is 1. And so the limit of the function given when x tends to infinity is half. Then one more question a student has asked, so we're going to do that, which is limit x tends to infinity 2 minus x and 3 over x. So by using the limit law, we know limit x tends to a f of x over g of x. So that would be, we can say limit x tends to a f of x and limit x tends to a g of x. So this is limit x tends to infinity 2 minus x and limit x tends to infinity 3x 3 raised to power x. This would give us a limit x tends to infinity 1 over 2x and this would give limit x tends to infinity 3x. So here we see that as x increases 2 over x as would increase 2 over x would increase and 1 over 2x will decrease and it will be close to 0. And same way here, as x increases, 3 over x will increase and it will be close to infinity. So this would result in 0 by infinity, and we know by infinity value property this is will be equal to 0. So limit x tends to infinity for 2 minus x and 3x is equal to 0. 3x. Okay. Now we'll do another question which a student has sent. Just now having another problem where limit x tends to 3 minus x minus 3 plus x minus 4. So this is a sign of absolute value, and this is greatest integer function. So greatest integer function we know is the step function. It rounds up to the greatest integer that is less than or equal to that number. Like for 1.5, it would be 1, and for negative zero point 0.5, it would be negative 1. So here, if we want to find the limit, and that is uh, to the negative side or the right left hand limit for 3. So the both this is the function and this is 3. We want to find the left hand limit, like something less than 3. So here x is here and h is a small distance away from 3, a small positive number. So we put x as 3 minus h because it is less than 3, a very small uh, value less than 3, h is a very small one. So now substituting h, and h tends to 0 because it is a very small value tending towards 0. So this would be 3 minus h minus 3, and this would be limit h tends to 0 for 3 minus h minus 4. So this 3 and 3 would cancel it out. Limit h tends to 0, and this would give minus h. This would give limit h tends to 0 minus h minus 1 absolute value. This is negative h, so negative side of 0, so it would be negative 1 because greatest integer function is a it rounds up to the greatest integer that is less than or equal to that number. So this is less than it, so it is negative 1, and the absolute value here would be h would be 1 plus h. Okay. So this would give us or if we go one step back, this would be just minus h, and this would be absolute value 1 plus h. So this is -1 and limit h tends to 0. So this is -1 and 1 plus 0. So this gives out C. Here absolute value of negative h -1 would be 1 plus h. Now the next question, somebody has asked, is f(x) is given like -2x square plus 4 and 4x raised to power 4 plus 8x square plus 1. So if we and we have to find limit from x tends to infinity and limit x tends to negative infinity. So if we put infinity over in place of x, we end up with infinity over infinity, which is indeterminate form. So this, uh, in this, the another thing would be, which we would do is factor out the highest power of the denominator. So this and this would give us, and this would be x raised to power 4, 4 plus 8 x square 1 over x raised to power 4. So here, if we take out, this is x square minus 2 plus 4x square, and this gives the absolute value of x square. Square roots are always positive, so we need to uh, take the absolute value to make sure that it gives a positive number. Though here it is x square, but this step will be useful when x is odd also. So this is 8 over x square and 1 over x. Now we find limit x tends to infinity. So this would be minus 2 over x. Now as it is x square and x tends to infinity, this would be positive, and this would be 4 plus 8x square plus 1 over x. So now finding limit x tends to infinity, -2 plus limit x tends to infinity, 4 over x square. So in the numerator, we see x tends to infinity, that will give this. And 4 over divided by infinity gives us 0. Here, this gives square root of 4. 8 divided by infinity is 0. And 1 divided by infinity is 0. So this will give minus 2 over 2, which is negative 1. Same way, if we want to find limit x tends to negative infinity, so it will be x square minus 2 4 by x square. So even if x is negative infinity, these are all even powers. So this would be positive. It would again give us negative 2 plus 0 and 4 plus 0. 0. So therefore limit of the function x tends to infinity and x tends to negative infinity is 1, is negative 1. So therefore the function has a horizontal asymptote at y is equal to negative. Now one more problem dealing with the limit x tends to infinity and negative infinity, which a student has asked and I try to solve it. So this is different from the previous question because here are the odd powers. So let's see how it makes a difference. So to find it out, to further simplify it, here if we have to find a limit x tends to infinity. If we put infinity, x is infinity, it gives this, which is a indeterminate form. So then let's try to manipulate it. So if we take the highest power of the denominator and factor it out. So this is x cubed, 5 over 1 by x cubed, and if we factor out x raised to power 6 in the denominator, this gives 1 over x raised to power 4 and 4 over x raised to power 6. Okay. So this would give x cubed 5. Here we take out square roots are always positive. So we need the absolute value bar here so as to make sure that this gives a positive number because square roots are positive are always positive. So we need these absolute value bars here so as to make sure that it gives a positive number. So this gives 3x raised to power 4, 4 over x 6. Now in this case, we need to find the limits to infinity. So, and we need this function which is given here. So in this case, x cube will be positive. So this would be, so this would give us 5. 1 over x cube as x tends to infinity would give us 0. This would give 3, and we know x tends to 1 over infinity 0 and 4 over infinity 0. So this would give 5 over under. So this gives 5 over under root. And for the same function, if we want to find limit x tends to negative infinity, we put the, as we remove the absolute value bar from this, it will be, we'll take it out as negative. So this would be x cube, negative x cube, and 5 plus 1 over x cube, and 3 plus 1 over x4, 4 over x cube. So this cancels, and limit x tends to negative infinity, 5 plus 1 over x cube, and this is negative 3. This we put as negative because the x is negative, going towards negative infinity, and this is the cube. So we took out negative 1 here. So this we know 1 over negative x cube will be towards 0, and this would give us negative 5 over under root 3 plus 0 plus 0. This would give us, so limit of the function x tends to positive infinity was 5 over under root 3, and limit x tends to negative infinity f of x is negative 5 over. So we'll deal with more problems in the next class. Please feel free to send me your difficulties. Thank you. Thanks for joining.